Mutest du dann immer hin und her?
Nee.
Dann sonst stelle ich mich irgendwo hin, wo es leise ist,
genau.
oder?
Also, genau, du kannst es auch noch, oder ja, lass einfach alles,
Nee,
ist ja eh gleich, dauert ja nicht so lange, genau. Läuft? Moment. Mal kurz Video gucken. Mal kurz Video gucken.
Ah ja.
War noch eine leere Türe, auch als du davor standest.
Das war was?
Das Bild hat sich nicht verändert, auch als du davor standest.
Echt?
Ja.
Oh. Krass. Das müsste aber eigentlich. Sollte sich eigentlich verändern. So, Moment. Guck mal, das kann man ja, muss ja gar nicht hingehen. Nee, tatsächlich.
Robert, haben wir Leon schon verloren?
Gut Catch, weil das sieht jetzt sehr vertrauenserweckend aus
ja,
gerade.
geil.
Mach sie einfach nochmal an. Achso. Okay, warte mal, ich mach mal.
But I can't say the things so loud.
Ja.
Gut gesehen.
So, okay,
Let's go.
let's go.
Alles gut?
All right, let's go. Okay. So, welcome everybody to PyData Südwest number 24, so the PyData Heidelberg 2011. It's great to see so many here because we were not really sure about, hey, it's August, do you want to go to the swimming pool or go to Meetup? So we're also streaming live on YouTube. That's why there will be some information for the people viewing at YouTube about where we actually are. So actually PyData Südwest is located here. We are in Heidelberg, and if you don't know where Heidelberg is, because there's also Heidelberg University I found out in the States, but we're actually in the original Heidelberg town with the original castle. The location is down here in Germany. Why do I push this a little bit more to an international audience abroad? Because everywhere I go to a conference, people ask me, oh, you're from Germany? Oh, you're from Berlin? I said, no, I'm not from Berlin. Berlin is over here. And let me show you where the most important universities in Germany are, and the excellence, like the elite universities, are also like located here, and also like the important companies of Germany also, like this is the actual distribution. So Germany is different. Not everything is in the capital as in many other countries. So I think it's good to point this out a little bit more. So so we are actually here working, too much geographics here. So this is Heidelberg again. So we are here in Paretos. Paretos is hosting us today. Paretos is a startup in Heidelberg. We are at Palo Alto Platz, which is also no coincidence because Palo Alto is the what's it called, partners city of Heidelberg actually. And enough for that. So it's very important always we are welcoming community. We want to see who's around for the first time. So please raise your hand if you joined this meetup the first time. So, well, not me, like this. Okay, wow, like it's always like 50%. That's always great to see. So but it's also really good for you to know you're not the only new person here. So this is very welcoming community. So if you want to talk to people, just like start chatting. So welcome. And I want to tell you a little bit more about what is PyData about. PyData was founded by NumFocus. NumFocus is a US-based foundation that supports open source software. So many packages you use, like Pandas or NumPy or Jupyter, are actually also supported and co-funded by NumFocus. And NumFocus one day had the idea to, hey, let's do PyData. Actually, the idea was quite a long time ago. So actually the first PyData conference was almost 10 years ago. So it's actually, so there's next big celebration next year, probably in Berlin, we'll see. And it's very important for us to be a very welcoming community. So there's a code of conduct. So we don't tolerate any harassment in the community members in any form. Please feel free to go to the NumFocus website to read the full code of conduct. And if you ever have encounter anything, please contact, talk to organizers, me, Kevin, or you can also like do a final report over the website. It's very important that everybody feels welcome, and this is and we have a healthy community and friendly for all. So a bit more about this meetup, or like Meetup, the PyData Meetup in general. The PyData Meetup actually has a lot of chapters. There's in total 221 groups now in the world. They're in 76 countries with more than 200,000 members. So it's still growing. So, and you're a part of that as well. Also, it's very important. That's why we also decided, hey, let's take an extra hassle, record the talks and stream it on YouTube. For us, especially for the conferences, it's important to share the knowledge which is presented at the conference with the world. And actually, there's now more than 3,000 videos with 150,000 subscribers on YouTube, which is, we only have 12.5 million views. But I mean, we're a niche topic. We're not Gangnam Style or something like that. But if you say like it's for a niche topic, still like it's which we're not pop music or something like that. I think that's pretty solid. And also like about this meetup, PyData Südwest. Actually, we missed our birthday in March. So actually, it was founded 5 years ago with the Pandas documentation sprint, and we were actually like 2 people at this meetup. So I think we have grown a bit in the past. And the meetup actually was, we founded it after we had the PyCon DE, the German Python conference, which had a PyData track in Karlsruhe. And we said, hey, we all like a lot into data, and so let's do a local PyData chapter. And there were people from Karlsruhe, from Heidelberg and Mannheim, and we said, it's a little bit ridiculous if we have like 3 chapters here, so let's combine this because the area is closely connected. So we actually like 1,550 members now. Please ping us if you want to host us, or you can also like talk to your company if you're interested in hosting. We're always looking for hosts like this, like, hey, you have a nice venue or something, and people can gather and we can present talks and the community can meet. It's also very important. Communities always give and take, so we love if you also step up and say, hey, I have a proposal for a talk. And you can just also like submit this via form with a link here, or you can also just start easy with a lightning talk. So I'm really happy. So we have like 3 lightning talks today already, and we have the first one for the next meetup already as well. So things get going. All this wouldn't be possible with sponsors. So today I'm very grateful that Paretos is sponsoring us for providing the venue, the food and everything. Königsweg, my company, we are all supporting the event organization from the very beginning, and of course I'm focused for promoting open source. And I would like to introduce you to Fabian. He's the CTO from Paretos.
Hello, I will just start like this. Yeah, hello, and nice to meet you. Nice to see a lot of new faces as well. Happy to meet. As I said before, feel like home today. Drinks are in the fridge, and looking forward for some nice talks and good conversations. In general, why we host this meetup, I mean, I have 2 slides about our company, but actually that doesn't matter too much, because why we host this meetup is because we think that in this area there are a lot of brilliant minds. We have good universities in all of the 3 cities that you mentioned. And it's all about bringing things together, because I think we can build something big out of here. And I believe in swarm intelligence and people connecting from different experiences, why data science project failed, and so on. So that's why we push this, and hopefully, grow together as a community even stronger. So thanks, Alex, again for organizing.
Thank you.
Little applause. And perhaps just super brief, what motivates us as Paretos is there's so much Excel out there, and this sucks. I think there could be a much better solutions for a lot of problems, but I think I can speak for all of us in this room, it is not only technology. I mean, a lot of the papers were written 50 years ago, but somehow still people use Excel or gut feeling. it's also about how to connect and how to build solutions, how to listen to people in order to use the things, because these are often not data scientists that do the decision in the end. And we try to, do our little part in it to build this bridge when it comes to we have technology and how do we make it applicable, especially in supply chain areas. But again, I think Robert will give some more insights later about the interesting data science part, and I keep it for this. Like now, I think after the break, there will be some good pizza. Actually, all pizza stores are on vacation in Italy, except of one. So that was the only bad thing that we didn't include in our future covariates. But we made it. We found one last pizza store, and looking forward for this evening today. Thank you.
Thank you. Yeah, all right. So probably many of you know, I'm Alex. So I'm partner at Königsweg. We specialized in data engineering and data strategy, and we're always looking for bright minds. So if you feel joining the team, or if you just want to chat, just come by and let's talk. So we need a little bit more support from you as well, because we thought about Meetup is a little bit slow, and it's really hard to connect. And we were thinking about, oh, should we do our own Discord? And that's another silo chat. So what the idea was, let's do a LinkedIn group, which was founded just a few months, like 2 months ago, and just join in. And you can also help, like invite other people you think they are really interested in. So for us, it's very important. It's a moderated, spam-free environment. So we're really cautious not having like tons of recruiters in there, or like people who just like, just share noise all the time, because it's so it's important we keep this healthy. But of course, who knows 3 Fragezeichen? Yeah, okay. Who knows the Telefonlawine? So basically, it's really easy. If everybody just invites 2 friends, and there's 2 more friends, and then we can basically reach everybody who's also here in our area. We have a chance, because I know we haven't reached many people, like especially in institutes. There's been tons of people using Python, and they never heard about us because they use different channels, and there's still stuff to do. So that said, we now have finished with the welcome. So I would like to announce the agenda. So we start with Robert's talk first, then we have a pizza break, and then there's a talk from Leon coming. After that, we have lightning talks and networking and the end. And you see the talks and the lightning talks we will live stream, not the networking and the pizza. That's impossible. I'm happy to announce 3 lightning talks today. So we have 3 lightning talks. We have Bertrand, who talks about locating the spiral arms of the Milky Way with T-Sense. Are you? Yeah, here. Oh, that's you. Hello. Yes, welcome. Oh, first time attendee and a lightning talk. Wow, welcome. That's cool. That's cool. Yes. So then we have Bernhard, who I've seen Bernhard. There is a second lightning talk. Yeah, developing AI as business analysts, data analysts using OpenAI and function calling. And we have Tim from Tim here from Open Source Science. All right. Okay. Without further no, one more thing. Community announcements. So, who likes barbecue? Okay. So where do you would think the big PyData barbecue? Many of you know here already anyway. So so the big PyData barbecue, many would assume to have this in Texas. It was my pleasure to do this presentation in Austin, Texas at SciPy, because everybody in Texas, barbecue is Texas. And so now it's actually here in Heidelberg. You see, if you have noticed, also like for people who watch the stream, okay, here's the castle again. We just have a different angle, and the barbecue is actually at the Mathematikon, which is the faculty for mathematics in Heidelberg, and I'm very thrilled. We have Ines Montani here from Spacey as a speaker, and Alessandro Saucedo from Zalando and the Institute of Ethical AI and Machine Learning as speakers. And there will be a lot of networking, and it's next week. Next month, sorry, on the 21st of September. So please sign up. We already have like almost 100 people signed up, and we already have the first lightning talk for this already, which is the first time ever. So very welcome. Who likes stop waffles? Oh, very good. So PyData Amsterdam is coming. It's actually next. It's just a week before the barbecue. So yeah, it's always a great conference. It's also like the first PyData Amsterdam after the Corona break. So I'll be there, and yeah, so check it out. And if you want to attend, there's a community voucher. Just talk to me. Who likes Döner? Oh, what could this be? Of course. Yeah, I'm really happy to announce we have the dates for the next PyCon D in PyData Berlin coming in April 22nd next year. Save the date. It's actually 10 years of PyData Berlin, and then actually it's 10 years. Yeah, 10 years ago there was EuroPython. PyData Berlin was the first PyData Berlin was a satellite event for EuroPython, which was actually by the PyCon DE team. And fun fact, it was my first EuroPython ever. And yes, and see where it got me. Yeah, also, there we have always like a constant call for speakers. So if you have something you want to present, like a lightning talk or like a full talk, just submit an idea. Yeah, it's always important to the community shares the expertise with other people and members in the community. Our Meetup is a safe space, so it's also like I think a great opportunity to train for a big conference talk. There's conferences coming next year as well, and also like organizers are happy to mentor. So if it's your first talk, just ping us and we can give you some insights. And we have Slido to ask questions, especially for people who join remote. You can also find the Slido link on the Meetup page. If you have any questions, just write them there. And now I'm really happy to introduce Robert over there, mic's on, and with his talk, Beyond Toy Datasets, Time Series Forecasting for Real Business Problems.
So, we see that we can't see anything.
Yeah.
So it worked before, right, Alexander?
Yeah.
Yeah.
Reboot always works, but can you see this also?
Ah, wait, I think now.
Oder das Thunderbolt am besten.
Soll ich es einfach noch ausmachen?
Ja.
Wir kriegen auch hier nichts rein.
Das war ganz kurz da, aber dann.
Das war ganz kurz da? Ja.
Dann ausschalten.
Techies with tech.
Am Laptop noch die Quelle. Jetzt ist
Jetzt, Achtung. Ja, der Verhandlung.
Okay, so.
Ja.
Perfect. Nobody touches anything anymore. All right, cool. Everybody welcome in our PyData office. First of all, I want to thank you that it's a big honor for me giving this talk to you and telling you something about my daily work and working with time series data, time series forecasting. So I'm really honored giving you this talk today. The name of my talk is, as you see it, Beyond Toy Datasets, time series forecasting for real business for real business problems. My name is Robert Hase. I'm a physicist, studied here in Heidelberg from bachelor's and master's. During my master's, besides working in condensed matter physics, I was deep diving into forecasting models. Sorry for that. Okay. I don't touch anything. I was deep diving into time series forecasting a lot. Also, I was investigating and studying back in 2019 already transformer algorithms and also implementing my own transformer-based algorithms, brought them into production. And I think it was at that time that when I realized that there's great potential within those algorithms, namely being transformer-based or being any kind of deep learning technique, and that we should use them as well next to other more fundamental statistical methods or machine learning methods. Back in university, I was then very, very motivated to just use my knowledge about all this technology and then just go into the industry and just apply it. But then I brutally experienced two things. In reality, in real business problems, like Excel still seems to be the best practice. And secondly, the data sets I was working with then in industry were not as beautiful as they were in university. They were not like preprocessed for me. They had gaps. They had everything, but it was not nice. It was not that beautiful. So especially that last point motivated me to give this talk to you today, because I want to emphasize basically the differences that we see in real-world scenarios, and also some concepts that need to be applied in order to cope with those real-world scenarios and with all those little traps that you can basically walk in. And basically what I want is, the goal of today would be that you understand the basic concepts, the basic ideas of, if you ever find yourself in the situation of coping with time series forecasting problems, you do understand the basic concepts and ideas of it, and you'll be able to avoid those pitfalls and just turn your use cases into a success story. Yes, so I think Fabian's already said, gave us a small outline about Pareto itself. For me, working as an AI scientist here, why I see our approach as superior is because we don't stop at purely implementing or deploying machine learning models itself. We don't stop at the prediction itself. We want to use the predictions and put some optimization on top of it in order to not only do the predictions, but also enable decision makers to be able to do optimal decisions on top of our artificial intelligence. I think, sorry for that. Yes. I think it's very important to leverage to help decision makers making optimal decisions within complex environments, and this is what we at Pareto strive for. All right, let's look at our outline. First of all, I want to give you a brief introduction into time series forecasting in general. Afterwards, Fabi, kannst du gucken, ob du ein anderes Docking Station findest, bitte? Secondly, I want to talk about to go from toy data sets to real-world business problems. I will explain later what I mean with toy data sets, but I think this is a very important distinction we should make here. And third, but not last, I want to give you some ideas of how modeling in real-world scenarios does look like. What are the things, the pitfalls that you have to be aware of in order to turn use case into success stories, and also especially in the give you some examples in the analysis of what you need to take care of as well. So first of all, probably you all know this guy for our international spectators. Okay, this is Günther Jauch, one of the big German quiz masters or show masters, and he's asking you the following question. And I want you to take out your phone, or I don't know if you have pen and paper with you, and just type in, what is the first and most important step when doing time series forecasting? Okay, we have answer A, which would be the hyperparameter tuning. So if you run a machine learning model, you need to optimize it. We all know that, so definitely important. We have running the baselines, meaning running some simple models as well next to some other models. Might help you, might doesn't help you, I don't know. C would be use the latest state-of-the-art models. We all read about transformer models, we read about NLP-based models, multi-layer perception models. Maybe also always being up to date can definitely help you with the results. Or D, ask ChatGPT, what am I actually doing here? So please write down your question. I will reveal in the end what's my right answer at least. Okay. Ich glaube, gerade funktioniert es, aber lass mal hier. Ah, shit. Yeah. All right, that was good. Sorry, I just changed my docking station. Yes. Ah, this is not right. Display settings over. Duplicate slideshow. Sorry. Does anybody know where to click here? Which one?
Right click.
Yeah.
And hide presentable.
Hide, yes. Almost. I see it very good. Okay, perfect. That is perfect. Thank you for, thanks for being so patient with my technical issues. You know, deep tech is not always that easy. All right, I wanted to give you a brief overview about what time series is about. Actually, it's quite easy. You're basically, what you're doing is you're predicting some future observations based on your historical values. I mean, time series, normally it's not that widely spread in, it's not like a classical machine learning technique or like an area, but we see those time series basically in every company because every data that is tracked over time can basically in the end be implemented and formulated as a time series problem. Where we see the most, the biggest leverage is, for example, in e-commerce companies where they sell, like they have a big e-commerce shop and they sell 10, 20,000, sometimes 100,000 different products, and they need demand for every single product in order to make their supply chain effective. So knowing the time series, the demand in this case upfront, is a big advantage for their business. Secondly, we also see, for example, finance is, for example, stock forecasting, all that stuff that is tried, sometimes more successful, sometimes without any success. But these are classical areas of time series forecasting. Let's don't get distracted too much by the whole mathematical definition. All I want to show you is basically that we do predict some targets Y based on some feature matrix X. We can therefore also, since we predict multiple targets at the same time, we can basically explain the time series forecasting as a multivariate regression problem, where you just predict multiple targets at the same time. What is important is what kind of features do you have? You do have, for example, the KPI itself. If you want to predict the future demand, you have to take your historical demand into account. You can take historical features into account, meaning was your stock filled at that point in time or not? These are important information in order to predict the demand accordingly. Also, what is important is, for example, future information, future covariage, which are denoted by this. For example, is there a sales day upcoming? What will be the weather tomorrow in Heidelberg or in 3 days in Mannheim? These are all important information that we need to take into account in order to make this prediction more accurate. So now I brought you a really simple example, which is the air passengers data set. The air passengers data set is just the data where the air passengers being tracked, how many flights were taken between the years 1949 and 1961. And as you can see, this is one of the data sets that is often used for benchmarking your model. So you see, if you read papers in this area, you see a lot of times, okay, let's benchmark on air passengers. There's also other typical benchmark sets like Boston house prices. This is what you read everywhere in the papers. So these time series, not all of them, but most of the times, they do have some simple characteristics that are that we can fit for. For example, here we want to characterize the trend of the time series. We see there's a clear trend, there's a clear upwards trend in this scenario. So this is like one thing that we have to fit. The other part that we have to try to characterize is the seasonality. So we see just before Christmas, the air passengers increases. Therefore, this is the seasonality part. The ultimate goal, basically, of time series forecasting is to identify trends, seasonality, but also the influence of external information. There are, like I said, other benchmark sets, the air passenger set, the Boston house prices. So this is what I was working on in academia, and this is what I refer to as a toy data set. It's only one single time series, not often super complex, but it has some characteristics that can be fit by normal time series approaches. But what we see in real life is that real life data sets, they're just different beasts. And I mean, they sometimes can look dangerous, they can bite sometimes. But today I want to give you an idea of how to cope with them, even though they look like that. Okay, first of all, one of the biggest differences is in these real-life time series data sets, we see tons and tons of multiple heterogeneous data sets, meaning you can have arbitrary many data sets, data points, products in a portfolio that can exceed 100,000 of SKUs that all have to be predicted separately. And when I say there's a lot of data, there is really a lot of data. And then there's data everywhere. Okay, so really, just imagine we have 2 million or maybe 200,000 SKUs times the historical part of 2 years on a daily frequency. It's like 200,000 times 730 days data points. This is a normal amount that you have to expect when working with real life data sets. What we also see is we have a lot of data sets, for example here, data spikes that are really driven immensely by external factors. So if you look on the left, there are also data spikes, but you can extract them, you can characterize them by the seasonality part, by looking at historical values. Here, we know, for example, here there was a sales day, so we have time series peaking up within 1 or 2 days and then drastically falling afterwards again. And this is all being influenced by external factors. So we have to take external factors into account, and we have to find the right models to take them into account in order to really come up for a proper demand prediction. Another one is the cold start problem. Cold start problem means there are products, time series, demand, whatever, where we have no to only less historical data for that. Just imagine you have a product launch here of a product that you never sold before in your shop, in your e-commerce company whatsoever. But you need to have like a picture in your mind, or like a roundabout number of what will be the demand. And just imagine you are sitting here on this pink line, and you know only that you sold nothing until now. What do? You can imagine it's hard. It's hard to get a proper prediction for that, but there are techniques. Last but not least, we see a lot of intermittent time series in real-world scenarios. Intermittent time series are time series where they consist mainly out of zeros. There is no clear seasonality or trend defined, and the data that you see here is more or less just noise. So it's hard to fit any kind of seasonality or something. It's really only that, and you have to cope with that. Since we see these time series a lot in different areas, I want just to have a little bit more deep dive on the intermittent time series, and just to give you an idea what can be done with that. This is also typical for e-commerces, where you have a product portfolio out of 200,000 products, or let's say 20,000 products, and 19,500 products are being sold almost no. And there are only 500 products that drive the whole revenue, and then you have a majority of products that are actually in a similar manner to that. And that is we need to find ways of coping with that. One way I want to show you today is the Crosstalk method. This is one of the most classical methods that you can use in order to model intermittent demand. there are further advantages, but I just want to give you an idea of what is possible, and then we can maybe have later on a discussion of what else is also possible in this area. So for the Crosstalk method, I just I wrote down in the bar the values for the time series just for visualization purposes. And then what the Crosstalk method does, for example, it models this one time series separately into two time series, meaning the first time series denoted here with the Q just holds the non-zero values, whereas the second time series, the A, holds the frequency of how often do non-zero values occur. In the end, these two time series here are fitted separately within an exponential smoothing formula. So this is a really simple formula. And you just get your prediction by dividing the predicted Q value by the predicted A value. For me, it's not super important that you understand every detail of that. There are also further advanced methods from the Crosstalk method, but just be aware of that there are techniques. If you look at data that looked like this before, there are techniques to cope with, and you should not naively just throw anything at it, because this will probably fail. Okay, this is the key message. All right, so we now looked at the data. We looked at certain criteria of the data. So yeah, so let's predict. I mean, what can possibly go wrong? I mean, every data scientist should laugh, because actually everything can go wrong if you're handling a data science project like this. But for now, we looked at the data, and we now just throw models at our problem. And I introduced myself as an AI scientist. So therefore, as a good AI scientist, what I do, of course, I pick all my neural networks that I have, just throw them at my problem, and I just see what comes out of that. And what could potentially come out, I mean, this is a plot that we see sometimes. I have on the y-axis, I have my root mean squared error, and I want to benchmark my n-hits model. This is like a super advanced time series model, MLP based, whatsoever, super nice. The TFT model, which is like a temporal fusion transformer, it combines LSTM, transformer network, so it's really, really hot shit. And I have my XGBoost, probably everybody knows that. So, I mean, I see here my n-hits model performs the best, it's the most advanced model. So I can just deploy my n-hits model, my work is done for today, and I give it to the customer, right? Or what's missing here? Does anybody have a clue what could be missing, like, in order to be really sure that this is a good model?
A real evaluation.
A real evaluation, yeah, we come to that in a second. Yeah.
A baseline.
Yes, right, okay, I don't have to teach you anything today. A baseline, correct, because having those results, just like that, it doesn't tell you anything. You could be really good, you could be really bad, you could be mediocre in between somewhere, you don't know. So having, for example, what is a really, really good leverage in order to convince customers from the business value you create is when your customer does his own predictions and does its own forecast, and you get the numbers, then if you're lucky enough and you evaluate his own forecasts, it could maybe look something like this. That's the easiest way. If you can show the customer what he does, and what you do with your models, you have such a margin of how you're performing better. This is the easiest win to convince someone that you actually provide business value for your solutions. If you do not have any customer data, any customer forecast, running baselines is your bread and butter. Like, this is something you have to do before every machine learning run. Because right now, looking at this plot here, suddenly we see that our naive baselines, and it could be various different baselines, statistical baselines, whatsoever, they outperform your whole machine learning fancy stuff. And this is not even that unusual that something happens like this. For example, especially for intermittent time series, we see that statistical models actually perform quite well with that. And having those baselines in place is super important in order to set your results into perspective. And you just said have a proper analysis. That's totally true. I mean, we're talking about data sets that are super nice. Having this global summary statistics, just looking at one number in the end, it doesn't tell you like the whole story of the underlying dynamics. Looking, for example, again at the data distribution, we see that we have also again some Pareto optimal situation where only 20% of products can hold up to 86% of the sales volume. And 40% of the products can hold up to 96% of the whole volume, meaning 60% of the products only make up 4% of your sales volume. Ignoring this data statistics in your analysis is you will totally fail by that. So for example, one possibly classification is by saying I analyze my products based on my volume, or I analyze them based on my variance, or I build some useful product clusters that reveal basically dynamics of the data set and also help you as a data scientist, but also your customer to understand what actually his problem is and how your performance is. And then your performance can look something like this, where you see, for example, oh wow, my deep learning model, my machine learning model does perform very good on A and B categories, but it does really poorly perform on C categories. And this helps you in order to improve your whole time series forecasting engine, basically. All right. So to sum it up, what is very important? What is most importantly, you should always be aware of your data and your underlying data distributions, and choose the appropriate algorithms looking at intermittent problems or this cold start problems. Also, I didn't talk about that, but this can be very promising. You can provide a mixture of models, combine the predictions, and give this as your final prediction. We also see some very positive results there. Secondly, choose some appropriate clusters on your time series data for your analysis, which is what is very important here. Analyzing your model performance only on clusters, it does not mean to only train on those clusters. Like, these are two different things, and we should definitely differentiate here, because training only on certain clusters is not a good idea. You miss a lot of information there. C, running baselines. Before using any machine learning, any deep learning model, before even thinking about that, running your baselines, doing your homework is most importantly, and without that, you're just missing context, and it's hard to convince yourself, your colleagues, your customer in the end. Right, so again, coming back to the initial question, who did vote for A? Nobody. For D? Yes. Perfect. And the ones voting for B, you were right. Okay. Yeah, nice. I mean, it's a highly subjective question. You could do.
ChatGPT would maybe tell us B.
We should check. We should check. It's a highly subjective question, but this is definitely one of the most key factors that you should do at every beginning of analysis of use case. Yes, that was my talk. I hope some concepts got clear to you, even though you're not even or you're not even working at the moment in this field. But keeping the data distribution in mind, and also like some analysis concepts that you should definitely be aware of. I hope it helps you. And yeah, thank you very, very much for listening. And yeah, I'm looking forward to the pizza and the chat with you.
So, thanks a lot, Robert, for the great talk. I think we have a couple of minutes for questions. At this point, there are no questions on Slido, so if you're looking remotely and you want to ask a question, please ask your questions on Slido. But you can, of course, also ask your questions locally here. Who does have a question?
First of all, thank you very much for the explanation. I could relate to most of the part because I think I'm doing exactly same stuff in my job currently. And just wanted to know your view about how important it is to retrain our model with the errors which you are having in actual, right? So for example, we made a prediction for this month and then we saw some actual. How do you think that the error which came between our actual and predicted values makes sense in this kind of scenarios?
Yeah, I think this is enough, right? So first of all, I think it's hard to give you like this explicit answer of how much retraining you should do. I mean, there are certain papers that tell you, okay, after 4 weeks, after 6 weeks, after 8 weeks, whatsoever. I think first and foremost, what is important to always track and log your real life performance. So because having only your testing data in place or your holdout set data in place, it does not give you, it does not ensure that also your model will perform like that also in live. So having this in place is the most important stuff to always be able to analyze also retrospective your results in a real life scenario. I think this is the most important step that you should do. Besides that, I think we saw, depending on the area, depending on the business, that after 6 to 8 weeks, we saw in some use cases some performance dip. So if this is like for us somehow some rule of thumb, especially working in high dynamic areas where it makes sense to retrain, but I think you will see it if you track it constantly. You will see it for each business and each data set yourself. Yeah.
Yeah, that was. Thank you.
Do we have more questions? Ah.
Hi, thank you for your talk. So just one question. You talked about like the state-of-the-art models, TFT, NH, and XGBoost. So when it comes to e-commerce industry, especially like fashion retail, where the data is very volatile most of the times, and you hardly have any historical data in many cases.
Yeah.
So from your particular experience, can you suggest which are the methods which really work well for what kind of product categories?
Yeah, good question. So what I would say and what we see is, I mean, there's a lot to say about that. So most important rule or most important fact is the higher your data set, the bigger that your data set gets, the more heterogeneous your data set is. So for example, we have data sets with, or sometimes I work with data sets 10, 20, 30,000 groupings, but I could take a relatively small model since the data set was not that heterogeneous to other data sets. So the data sets, they had similarities. So I didn't need that capacity of a big model to really be able to model all different time series. When we see bigger data sets, more heterogeneous data set, your model just needs capacity of being able to model intermittent, but also take exogenous variables into account, in order to being able to model influences of external data. All this stuff just means that the more complex the problem is, the more data you have, the more heterogeneous your data set gets, the more capacity you need. And we see, for example, that NLP-based NHITs, they're working quite well. Also, they're very effective. You can iterate a bit more faster, I'd say, than with transformer-based methods, because they just need a lot of training time, and you really need to look after learning rates and all that stuff. Then it's. So this is my rule of thumb. There are more advanced techniques. Sometimes also this one global model does not the best job. You need combinations of models depending on what data you're actually trying to predict. But yeah. Yeah.
Do we have further questions?
Yeah, thanks for the talk. I have a question about the cost functions that you use. Do you also sometimes use more exotic cost functions with your customers?
With the customers?
Yeah, maybe someone is asking, okay, RMSE, it doesn't matter to me. I want to make good decisions, as you also outlined. I want to measure, for instance, how do those models help me to make better decisions?
Yeah. So there's definitely. So first of all, what we see is that the metrics used to evaluate with the customer and the loss functions that you're talking about training our models, they are not necessarily always the same. having a simple metric function for your customer to be able to explain how good you are in like in numbers that are also understandable if you're not like a mathematician or something is very, very important. This has nothing to do with what we use as loss functions. But I think you were hinting on another point. For example, loss functions to see. For example, if over-predicting the demand is more costly for their own use cases than, for example, under-predicting. Meaning, for example, you overstock, okay, you have more cost in, for example, for your warehouse, but under-predicting is like really bad for you since you lose a lot of sales, so that hurts even more than just over-predicting. And on the optimization part, I mean, Fabian is the optimization expert here, but on the optimization part, we use more fancy metrics in order to display our actual value. On the demand prediction side, I think, from my experience, it's better to use more simple metrics and to explain the behavior of your model by that, and not too fancy metrics. I think on the optimization side, it's a little different, right?
And if you look at the coffee bar, custom metrics are really expensive because they always have caveats, and cause like if you optimize for them, always some things that you never thought about before.
Okay, thank you.
All right, we now do have a question on Slido asked by Gus, and I'll try to rephrase it or read it. Do you consider training time and model explanation? Stats and ML models usually trains way faster than neural networks and also helps you to understand a little more the data.
Yes, that is a really good question. So obviously, yes, of course, we include training times when choosing our models. I mean, thinking about it, training a statistical model can take some seconds, so you do not have to think too much about, for example, infrastructure, how you store your models in the end. You can basically, it's a trade-off, but you can also say, okay, I train my stats models just every time. It doesn't matter about storing. Obviously, for example, when you're using the neural networks, it takes much more infrastructure in order to make those models work. Explainability is a very good topic. I mean, you have some really simple models that are purely that provide some explainability from the shelf. For example, I mean, we're talking about linear models. Obviously, it's easy. You're talking about decision trees where you not really get, it's not super explainable, but you get at least some kind of feature importance. You do not get that from top of the shelf from the neural networks we're working with. That being said, there are also techniques that make your data, that let you explain your model even better, talking about Shapley values or something like that. You can, for example, combine the Shap values with your neural networks, and then you get at least induce some kind of explainability. For us, I think performance is highest prio. Secondly, explainability.
All right, thanks a lot. I would say before we move on, we give a warm hand to Robert.
Yeah, and now locally we'll have pizza. It has arrived already. We will be back at 8 o'clock. Thank you. jetzt tipptopp. Okay. Back on air? All right. So welcome back, everyone. I know everybody seems to enjoy the conversation, so a lot. Sorry for the interruption, but we have networking after the lightning talks as well. So I'm happy to welcome you all back to the second part of the meetup. So we are now, the next is Leon's talk. He will talk about LLMs for business with the Langchain. After that, we will have free lightning talks, and after that, you can continue all the conversations I just interrupted. Sorry. And yeah, so please give a warm hand to Leon. Noch nicht?
Okay. Again, technical difficulties, but now with the mic, I hope my HMI works. Okay, cliffhanger there. All right, everyone. Happy to be here. I'm excited for today's talk. First of all, thanks for Paretos for hosting this event. And now are you serious? Okay, it works. I'm not touching it. I feel you, Robert. Yeah, thanks for Paretos for hosting this event, and thanks for PyData for having me. It's actually my first PyData conference, and then as speaker, so it's an honor to be here. And the topic for today is Langchain, which is an LLM framework, which you can get the full potential of LLMs out of LLMs with Langchain. And yeah, but before I start, I'd like to introduce myself. This is me, and this is my picture. And here are some facts about me. I studied mechatronics originally at Hochschule Mannheim, and I focused on artificial intelligence in my master's. And originally, I worked in the CV area, so I did a lot of pedestrian detection with LiDAR and radar data, and this was also my master's thesis. And yeah, originally I wanted to do a PhD afterwards, but I got stuck in building stuff with value, and this is why I joined Snox, because I saw great potential in the company and in the e-commerce bubble, as I say, and especially with LLMs, which I work nowadays mostly. Yeah, and it's a lot of fun. It's an open playground for AI, and this is why I'm excited about it. And yeah, some personal facts about me. In my free time, I'm a triathlete. I do a lot of swimming, cycling, and running. Yeah, so far so good about me. Okay, this is our roadmap for today. First, I'm going to give a small introduction, what Langchain is and why you guys should use it and why you should play around with it. Then I'll present some features of Langchain which I think give the most value for companies or for your personal fun or your personal interests. And then I'll provide some example applications which we use at Snox and which I think every company can use to leverage LLMs. Then I'll give a short summary, and then we'll have the Q&A. All right, let's get right into it. What is Langchain and why should you use it? Basically, Langchain is a framework which makes the work with LLMs, with large language models, way easier. So basically, you can think about Langchain as a connection between the LLMs and the outside sources, which could be Google, which could be Wikipedia, which could be your own docs, which could be like Notion, and yeah, basically it makes the connection between these two parts or these two sources way easier. How does an application including Langchain look like? You would have a normal front end, could be like Streamlit, or it could be a normal React front end, which we have at Snox. And then you have the Langchain framework or the Langchain application between the front end and the large language models. And basically every function in Langchain is to make the LLMs more accessible. Right, then one could say, why do I not simply use the Open API? And that's basically a valid question, because the API is just fine. You can use it for simple prompts, and I think every one of you has prompted ChatGPT before, and this is the same with the API. If you have a simple input-output problem, then just use the Open API. But I'm going to demonstrate in a second where the value of Langchain is with a simple example, and then you'll see why Langchain is so good and why I'm so excited about it. Okay, let's switch. Okay. Can you see that? Yeah. Nice. Okay, I've prepared a little Jupyter notebook for every feature I'm going to present in the first. What is it called? I don't know. In the first cell, nice English. You have the basic imports, and then am I in the right? I'm not in the right notebook. I'm sorry. Basic imports, like I said, and then this is what you would do for the normal ChatGPT API or GPT API with a little helper function, which is called chat, and then you return the response. And of course, this is not too complicated, and it works just fine. Like I said, for the simple question, tell a joke for AI scientists, it works just fine. And this joke is pretty bad, so let's move on. And in Langchain, in a nutshell, is that it's just way less complicated. So you can see you can do the same thing in just 2 lines of code. So and of course you could argue, okay, why does this provide value? But you can imagine the more complicated the problem gets, the more value Langchain can give. And this is what I want to demonstrate in this presentation. Okay, then let's jump back into the presentation. You can see it again, right? Yeah. Okay. Okay, features of Langchain. There are a lot of features, too many to handle in this presentation. This is why I want to focus on prompts and how Langchain handles prompts, because I think that's a pretty good touch point, because everyone has prompted for GPT, and this is a good entry point. I want to talk about chains, agents, and combinations with tools, and then the vector store integration of Langchain. Okay, let's start with prompts. And yeah, like I said, for basic prompts, just use the API. And but for more complex prompts or even dynamic prompts, Langchain provides a lot of tool sets which make the work just a lot easier, which I'm gonna demonstrate in another example, which I prepared for today. Let's see. Here we go. Now we go into this. No, that's the right one. Okay, this is basically, after the normal imports, this is basically the same thing which we did before. We define a prompt, and this time it's an e-commerce, because I'm biased. I have to use e-commerce examples. So here you can see we should write a product description for boxer shorts from Snox on Amazon. And yeah, after a short waiting time, and this is what the LLM provided. It's not that important right now, but this is where it gets interesting. And you can believe me, if you would do dynamic prompting with standard strings and standard variables, it gets messy pretty fast. And you can see we have 4 input variables. So we have the text type, product, brand, and marketplace. And we can dynamically access these with the template and the prompt template, which which we get from the template. And then all we can do, or all we have to do, is define our text types, products in lists, brands, marketplace, and so on, and loop through them. I'm not going to run this right now because it's expensive, and it takes some time. That's the bigger problem right now. And then you can iteratively just produce a lot of text really fast, and it's not that complicated. It's just these few lines of code. And I think that's pretty amazing, and we use that all the time when building our tools. Yeah, and that's, I think, a good entry point on why Langchain provides so much value, at least for us. Okay, so far so good. Let's jump back to the presentation. Here we go. Okay, next I'm going to talk about chains. I'm only going to talk about LLM chains because I haven't worked with the other chains. There are a lot of chain variations in Langchain, but I only have worked with the LLM ones, and I don't want to talk here about anything I don't know. So this is why I'm going to stick to LLM chains. And a chain is basically a wrapper around different components of Langchain. And because there's, what does it mean? It means basically that you're combining different LLM calls and actions automatically. So I'm going to demonstrate that in another example. Here we go. So imagine a world where you have to give a PyData talk in 1 week's time, and you have no idea what to talk about, apart from an introduction, a structure, which you have gotten from ChatGPT. Definitely didn't happen for me. And yeah, then I thought I could build something with a chain, which helps me out on that. So I have my basic structure here, and then what I do is I put it into a template, and I provide the template, or I give the template the structure, and then that's what I did before. I create an LLM, I create a prompt template, and then I create an LLM chain. And this LLM chain gets an LLM and a prompt template, and the output key is improvements. So basically what it does, it gives me improvement recommendations for my structure. So this is the first part of the chain, and the second part of the sequential chain will be another LLM and another template and another chain also, which takes these improvement recommendations and puts them into my structure. So it implements them into the structure. And this is how you can optimize concepts really fast. And we at Snox have a tool which creates concepts for us with dynamic inputs, which we can choose. I think that's pretty amazing, and this is a light open source version of that. And what I do next is I put the two chains into the sequential chain object, and then the two chains run after each other. So, and then I run them in a loop, and then, as you can see, it goes through the iterations, and then in the end I get the better structure. So, and you can like extend that. I'm going to talk about vector stores in a minute, and you can I could every time a new iteration starts, I could like feed another snippet of the Langchain documentation in there to get more input into the model and more knowledge into the model, and so refine the structure even more. And yeah, or you could integrate an agent, which I'm going to talk about as well. Okay, then this was everything about chains. Back to the presentation. Okay, yeah, vector stores. Does everyone know what a vector store is? I think we're in a good environment for that. Okay, good. Basically, what Langchain does, it makes the combination of LLMs and documents very easy with their own vector stores integration. And this is actually my favorite feature of Langchain. And I'm going to show why, because this is basically the go-to application. And this is, I think, also the reason why Langchain was founded in the first place, because they wanted to do stuff like that. I'm going to show another example. Jumping back. Okay, here we go. Okay, so we have some input, which is our input data, and I'm only going to show this part of the input, which are basically some questions our finance department would ask. Like, that's arbitrary questions which our finance department could ask, and this is basically oh shit, didn't want to do that. Sorry. Yeah, and what we do is basic here, and we load the text. Oh, why doesn't it work? Love it. Okay, now it works. Thank God. Got nervous. Okay, and then we split them into chunks, and we embed them like in a vector embedding, and it doesn't work again. Now it works. I don't know what's wrong, believe me. And yeah, we embed them using the OpenAI API, and then we load them into a vector storage using Pickle. You could use any vector storage. We use MongoDB, for example, or you can use Pinecone, whatever you like. But I think for this demonstration, this Pickle dump function is just fine. And then we can, of course, load it again, create a prompt template like I showed you before. Yeah, this is where it gets interesting, basically. We create a retriever object, which takes the LLM, the chain type, and then the vector storage as retriever. That's important. And then what we can do is we can query the vector storage with a similarity search, and over the LLM we can ask the LLM questions, and it answers based on the knowledge in the database. And this is like, I think, what provides the most value in Langchain, at least for us, it does. And I think that's pretty amazing if it would work. Why doesn't it work? I don't know, I'm sorry. It worked this morning. I'll try one more time, otherwise I'll move on. Does not work. Sorry, guys. Okay, then I'll move on, I'm sorry. Okay, next. Okay. The next thing I want to talk about are agents in combinations with tools. Basically, what agents do is, I've shown you chains, and I remember what agents do by thinking about chains that are undetermined. So if you have a chain, then you know what to do next, but an agent can make the decision on what to do next. And this is, from my opinion, pretty amazing. And basically, agents are in this area here, right here, and they make the decision on when the LLM needs information from an outside source, or the LLM makes the decision on when it needs information from the outside source. And I'm gonna show another example. I hope it works this time. Okay, it's a pretty short one. Okay, here, agents. Again, the imports. And then all we have to do is instantiate another model, and we have a tool called Math. It's the LLM Math, and it's basically a tool which can do calculations. And we initialize that, and then what we do is we initialize the agent with an LLM, and with the agent there are multiple agents. I just use this one here. You can read the documentation if you want to know everything about the agents. It's not that important right now. And then we ask it, how are you? And now are you serious? Ah, now it works, okay. Demonstration error, love it. Okay, moving on. What the LLM should do here is recognize that this is not a math question and that it doesn't have to do a calculation and does not have to use the tool. And it does it perfectly. So it answers, I'm doing well, thank you. So you see how the agent works. And then the next thing is we ask it what's 100 divided by 25. And then you see the LLM thinks, and it sees, okay, I need to calculate this. And the action is it uses the math tool. And then it calculates it. Of course, the LLM could have done it with the API as well. But if you have more complex calculations or more complex tools like Google search, or there's even a Wolfram Alpha integration for Langchain, which is pretty handy. And yeah, I just wanted to make clear how agent thinks, and I think this example is pretty cool for that. Okay. So far about the features. No more examples today. Here we go. Okay. I'm going to talk about the example applications which we use at Snox and which I think are pretty handy for almost every company which sells products or which has data. And I think the most commonly known example is the personalization, which I've talked about a little before. And it's basically you have a user on the left side which has a question like in ChatGPT, but the model not only knows what ChatGPT knows, but it also knows what's in your vector database. So you could basically, what we did is we took our Notion, for example, and we put it in the vector storage, and then you do a similarity search, and you can ask it questions about the company or about anything if you have the data for it. And this is quickly implemented in Langchain. I think it took me like 3 or 4 days. Of course, then you have to do front end and stuff, but the core application is pretty fast implemented, and it gives a lot of value, more value than I thought, because if you take, like, we are 120 people, and you make everyone like 2 or 3% faster because they don't have to go through Notion every time they have to find something out about a company. That's a lot of value, and I think that's a pretty nice and pretty simple application you can build with Langchain. Okay, the second thing I came up with is a notification system for customer reviews. So everyone that sells products could use this. So basically what you have as an input is customer reviews from, let it be Amazon, or let it be your own portal, or let it be like via letters or whatever. And you take, oh no, letters wouldn't work because that's not digital. Big brain here. Okay. Yeah, you take these customer reviews and you put them into the vector storage. Like I said before, you embed them using the OpenAI API, and you put them into a vector storage. And then what you do, you make some prompts on finding out the most important information you need for example, here for the product development team, and you summarize it using another LLM, which is pretty basic, But for the product development team, it's a huge step because they spend like 30% of their time, not 30, let it be 20% of their time looking at reviews, finding out what the next product should make better, or what's the best feature for our customers, which we definitely should stick to. And now they get a weekly report on what they should implement or should not implement in the next product, or what they should make better with the current product. So I think that's pretty cool. And then also with Langchain, this was pretty easy to implement. And the last example application which I have today is a bit more advanced, but I think it's again pretty clear. So you'd have a Excel or CSV. For example, in our use case, it's an ad report. So the performance of ads from Facebook, for example, and you put them into a data frame, pandas data frame, and you have rules for optimizing ads. So we have some rules internally how our performance marketing team optimizes ads, and this could be in any channel. And then what we do is we put them into Langchain. We initialize a pandas data frame agent, which is basically an agent working with data frames. And there you can get a lot of information out of these data frames. And what we do is we extract the KPIs, like our KPIs, which you want to track out of the CSV. And then we use our rule embeddings, which we put into a vector storage, combined with a chain for optimization recommendations. So you get like, when you combine these three things, like the KPIs, the optimization recommendations, and the rule embeddings in an LLM, you can get action recommendations. So you can like have the, for example, make the ad spend higher on this product or something like that. And then we have our users or our performance marketers look over that, and then they submit it or they decline it, and then we can directly upload the updated parameters to our ad portal, which is, again, this was a bit more work than the other two, but I think it's still pretty simple. Of course, there's a human in the loop, so it's not automated because it's for us it was not possible to do, or for me at that time because I was alone back then. Yeah, but I think it's a pretty nice thing. Okay, I'm coming to the summary. First, I said that Langchain is a framework which makes the work with LLMs way easier. The prompt templates make dynamic prompts easier for you. And I talked about chains, and yeah, I told you that they are a wrapper, and you can like add them together and make like these chains of actions and LLM calls. I talked about how Langchain has its own integration with vector storages, and how you can leverage that to, for example, build a chatbot. And I also talked about how you can use agents for decision making in an LLM, or like decision making on when to call different tools, and use Langchain as a connection to outside tools, or between the LLMs and outside tools, if you can say so. Okay, and I showed you a few use cases, but believe me, there's a lot more, and I encourage you to try out Langchain and work with it, because firstly, it's a lot of fun, and secondly, it gives you a lot of, or many benefits for you, and I think also for your company. All right, thank you. That's it from me.
All right, we now have time for a couple of questions. Maybe it would be a good idea to start by switching on the lights. I think that looks like a switch. Awesome. Hi, there are a lot of people. All right, are there any questions in the room? Yes.
Just a quick question about this nearest neighbor approach. Wouldn't that create a bias towards like individuals that don't have a neighbor because they're their kind of individual opinion? Someone says, "Oh, this product is crap because of X," so it would cluster all the similar opinions and the.
To be honest, I can't tell you anything about it because it's it's implemented in the Langchain library, and I just use it. I'm sorry.
Okay. Yeah, no, it's just a hunch. I wouldn't know.
Maybe you can talk to the founders, or you can contribute and challenge it.
Yeah, no, I don't know if it's just a hypothesis.
Okay.
Could be completely wrong on my side too. Yeah.
Never thought about it. I'm sorry.
Sure.
All right, are there any more questions?
So do you only use Langchain and the possibilities in there, or did you also think about like combining an LLM maybe for some other classical method? For example, use an LLM for feature engineering and then use the features for a classical machine learning model later on? Or maybe basically would be maybe the same thing, but to have a custom tool for Langchain, so not only the Wikipedia tool or calculator tool that is already provided.
You can build custom tools. There is a class for that, and we're definitely planning on using that. I have not played around with that because I started at Snox like 4.5 months ago. And now at the moment I work on the quick wins, and this is with text and the campaigns and all the I say standard LLM stuff. But my heart, like I said, I come from CV and standard machine learning, and I spend a lot of time with PyTorch, and I say I missed that a bit. So definitely planning on working on that in the future, but haven't tried it out yet.
All right, so to our remote viewers, there are no questions on Slido yet. If you are a fast hacker, then maybe I can get one more in.
Yeah, what was the craziest thing this stuff did, what you perhaps didn't expect? Perhaps why I'm asking, like I think when one employee that also used such an agent, and the agent, because I mean it basically writes code as well, just deleted the whole folder with all the stuff inside, and it was not revertible. So what did you experience there already?
I wrote an integration for our Amazon API, and I thought I deleted all our PPC campaigns, which is, yeah, for those of you who don't know Amazon, it's a lot of money. So that was a shock, but I only like moved them into a separate folder. So that's what the agent did. And at this moment I was like, okay, I get a new account and I make it like a test area. And I think that comes close to the craziest thing that an agent has done for me. So take care of you when you're working with agents. So
Thank you.
Any more questions in the room?
So you talked about these tools, and then the agent would choose depending on the input, like, okay, now I need to use the math part. Mm-hmm. Can it use multiple tools in one query? Like maybe you ask it like currency conversion question with math.
Yeah.
Could it like check, okay, I need to use the math, calculate, and then ask for like the Forex exchange rate?
The input for the tools is a list, so you can give it multiple tools. But sometimes if you have too many tools, then it gets confused on which tool to use. So it's, if you have a clear vision of your application, it's better. So you could think like, okay, I'm going to put all the tools in there. Why not? But like if you have a clear vision of your tool, then only use the tools you will use. But because otherwise it gets confusing. Then it sometimes doesn't use a tool when it should use it, and yeah, that's basically best practice there.
Any further questions? This is your last chance.
But it's nice to see you guys there.
Sorry about the light, but then let's move on to the lightning talks. Sorry. Good job.
All right. I have to update my slides first because there's something came up. So see here and. Yeah, just all right. So let me move this over here. So okay, why do I start with this? Because actually, thanks for listening. We just have 100 members, which is great. So. And next, oh, sorry, that's the wrong. So here, okay. Now we come to the lightning talks. I don't see anything on the screen, but I have all lightning talks prepared. So I would like the lightning talk speakers to come line up here. Who does know what a lightning talk is? Oh, there's a decent crowd. Yeah, so let me explain you. The lightning talk is you have 5 minutes and you can basically say anything appropriate in that. So it can be, yeah, that's the best way to phrase it. So it can be something fun, it can be an experience, it can be basically anything, but there's a hard 5-minute limit. There's no questions. And I'm going to take the time from the lightning talk. And if you see me make this, that's like 30 seconds before the lightning talks end. We start doing this, signaling the speaker, come on, speak up. There's like 30 seconds left. And then in 5 minutes, you just stop it with a big applause, no matter what. So that's the challenge. That's very scary. That's very scary. No, I'm totally, I'm confident you will manage, but maybe let me make things a little bit easier for you all, because the lightning talks are all on this machine, and I think it's easier if we just share the screen. Yes, then let's just let's sync. So, and now I think everything is way easier now, because you see the same. So,
yeah, perfect.
Please welcome Bertrand.
Yeah, so first I want to apologize because, as you can see, I'm an astrophysicist that is currently turning into data scientist. So probably there is too much physics in this talk and not enough data science for your taste, but well, I will do my best to still make it pleasant for you. So the idea is to use TSNE to detect the spiral arms of the Milky Way. And you can see on the top left photo, for instance, that beautiful galaxy with the spiral arms. And well, it's easy when you have a photo like that. But really on this talk, when this plot where the galaxy is a bit inclined, it's becomes very much more difficult to identify the spiral arms on something like that. And it can even be that you have a spiral galaxy with not really well-defined spiral arms. And then, well, actually I'm not sure what you would do in that case. And in the Milky Way, which is also a spiral galaxy, this is what you see. Because since we are in the Milky Way, well, we don't have external photos to identify the spiral arms, so we have to do it with, well, what we can do, but...
Clip this for the microphone.
Yep, perfect. Well, we cannot identify the spiral arms from the outside, so it's much more complicated actually in our case. So the idea is, well, you use what you have, that is coordinates for stars or whatever objects you use, and distances. And you are kind of bound to young objects, because otherwise they move from their birthplace and then they evolve away from the spiral arms, and also the spiral arms evolve with time. So you need to use young objects. And people have done that with masers. So from the acronym, you can guess that it's an extension of lasers, but except that they emit in the microwave. And you find those in around young stellar objects. That's basically stars in forming. So those have a few mega years. And we know something like 200 in the Milky Way. And these people, Reed et al., have made this model of spiral arms based on the detection of these masers. And what I did is using another kind of tracers for which you also get good distances, that are the Cepheids, that are pulsating stars. They are a bit older, so there is a chance that they already drifted away from their birthplace. But on the other hand, we know something like more than 3,000 in the Milky Way, which in principle helps us to properly locate the spiral arms. And you can see here on the distribution in a specific direction that the distribution of the Cepheids as peaks, that are the black curves, that matches quite well with the spiral arm models of Reed from masers. So probably it's a good tool to also identify the spiral arms. And I will skip some details because I guess I have no time. So here are the Cepheids located here. And just very quickly, you can see that there are some areas. From here, it's not very easy to see, but you see some blank areas in here. It's just probably at the bottom of this like cone structures. There is a big cloud that prevents from seeing what's behind, and then we don't detect the stars in this region, and that will have an importance later. So, well, if we talk about spirals, we will start with, let's say, the logarithmic spiral, and if you try to make it a bit easier, you go in a slightly different space where you expect to have linear features in the theta and logarithm of radius space, where radius here, or r, is a distance from the galactic center, and theta is just the angle. You have you start somewhere, you have a reference, and you turn around the Milky Way, and then you define an angle that way. And then the idea is, well, you try to use t-SNE, which is a dimensionality reduction algorithm, to try to identify groups of Cepheids, hoping it will do better and especially not biased like a human would be. And then, so that's what I did, and only using 2 dimensions, the coordinates, and that's what it looks in the top left in the t-SNE space. And then in the t-SNE space, it will be completely gray. And then I use HDB scan, which is a clustering algorithm, to identify these groups without human biases. And some of them are just bogus. Some are real groups, hopefully. And when you return to let's say, normal space, the original space, you find quite some linear features that you expected. And also, again, these bogus, like the orange or the pale blue here. Those are, so I guess I have no time to explain why, but we can chat later. And then if you return, let's say, the original coordinates, then you already see features that look like spiral arms. And then you can, on this linear plate, you can do a linear fit. And then you obtain this like olives segments on the spiral arms. They fit quite well with other methods, except this one, which was probably completely wrong. And maybe the good thing is that you detect new features. For instance, this one that has not been seen by any others. So I think it's a pretty, I was actually positively impressed by the results. I'm not stressed. Thank you. Very much. So I had to cut a lot, but we can chat later. Yeah. Thanks a lot. Oh, sorry. Okay.
Yes.
I don't see what I'm doing. So.
Okay.
Very stressful.
Okay. So,
Genau, also wäre super, wenn das dann Presenter-Mode wäre.
so, Ich habe die Bildschirme gespiegelt, ehrlich gesagt, weil... nee, doch, PowerPoint. PowerPoint nicht, okay. Perfekt. Okay, next up, wer fragt? Ja, Bernhard.
Bitte? Leg mal kurz deinen Arm, damit ich die Kamera habe. Okay. All right. Yeah, thanks for having me. I'm going to talk about the idea of developing an AI-based business data analyst using OpenAI function calling. So before I go into function calling, I actually first want to address the question, what about ChatGPT code interpreter, as this is currently getting a lot of hype. And so, for example, if you look on YouTube, there's quite some heavy claims there that code interpreter is going to be the end of data analysts, right? So I thought, all right, then looks like I have to give this a try myself. So I created a simplified version of a data set I found on Kaggle. And this data set actually tracks the page loads and the unique visitors for each day. And then I uploaded this to the CSV to code interpreter and asked it to plot the number of unique visitors per year. And so code interpreter then loaded and inspected the CSV. And afterwards, it generated Python code that aggregated the unique visitors by year. And then it produced a Matplotlib chart. All right, so this might look nice overall, but there's a big problem here. The correct answer would have been, this question cannot be answered using the data set, as unique visitors is a non-additive metric. This sounds very technical. What I mean by that is, you know, if a user actually visited the website each day in the year, this would result in this user would have been counted 365 times in this chart here. So the results are complete overestimation, actually. And so overall, I'm not very concerned that code interpreter is going to replace data analysts anytime soon. I think it's a tool that can greatly improve the productivity of anybody that can code with Python, but I don't think it's something that you want to directly expose to like non-technical business users. And this brings me to what I actually want to talk about, which is function calling. So imagine that we have a comprehensive retail data set. We've talked about retail before. How could we develop a data analyst chatbot that can answer a query like the one shown here using function calling? That's like the setup, right? And for this, we would first create a system prompt. And here I'm showing a very simplified example that states, you're an expert in data analytics, use the provided functions to answer the user question. You're working with the following data set, and then here I just concatenate the first 5 rows of the data set in Markdown format to give it some context. And next we have to describe basically the functions that the GPT model should use. For example, we can specify a function filter and aggregate, which takes a list of dimensions that should be aggregated and a dictionary of filters that should be previously, like before that, applied on the data set. And then we can also specify other functions, such as a plot TimeSeries function, which takes in a metric and produces a figure, for example, a Plotly plot. And we can then iteratively make this more complex. You know, we could add a lot more functions here, for example, something like plot forecast, or maybe even a function that would identify anomalies, or maybe even run SQL queries. And so the important part to understand here is that GPT will act like as an agent and will only return the function name and the arguments that it wants us to call, but we actually have to implement these functions ourselves and then actually call them when it wants us to call the functions. And so to make this more clear, I'm going to show one example in the action diagram. So first, as mentioned, we have the system prompt. So we send the system prompt, the user prompt, and the function specifications to the GPT model. And in this case, it would return the filter and aggregate function name with the arguments year, month, and store as dimensions, and a filter for city equals Heidelberg. So given the query, it thinks, okay, this would be the best function to, you know, fulfill this query. And so we would then execute this function locally, so basically in our analyst. And then we send a next request with the full conversation history, where we also include a markdown sample of the aggregated data frame. And the model then reasons that the next function that should be called is this plot TimeSeries function with the metric sales. And so again, we would run this function locally, And then finally, we would show the generated figure in the chat window. So this is like the high-level idea of how function calling can be used to basically develop custom agents that can, in this actually use case here, act as kind of a data analyst. And so I think overall, this is kind of the most promising approach at the moment, especially regarding production readiness for developing such a tool, because it has several advantages. You have full control over the generated plots. You can incorporate all kinds of guardrails. You can, implement integration tests, all types of stuff. But of course, it's not end-to-end AI. You have to develop these functions yourself. That's kind of the downside here. And then, yeah, we're hiring.
Yeah, so next up is Tim.
Kann ich einfach die einfach just check the browser.
Wir sind ja Full Service.
Super. Einfach
Full
nur
Service Meetup. And da, bitte.
Super. All good?
Yeah, I think it's.
Okay, time is running.
Okay, awesome. All right. Hey, everyone. Nice to be here. My name is Tim Bonneman. I work at IBM Research, and I'm here to talk about open source science. Open source science is a new NumFocus initiative that was launched last July. We are, so to speak, a cousin of PyData, if you look at the family tree. The goal behind open source science is to accelerate scientific research and discovery by improving the way open source software gets done in science. So unlike the enterprise or private sector, open source or research software in open source in science has to struggle with a lot of different challenges. Anything from lack of consistent onboarding for students all the way up to policy settings that prevent open source from thriving. We hope to accomplish that by connecting scientists and open source developers and other stakeholders in interest groups. We currently focus on chemistry, material science, life science and healthcare, and climate and sustainability. And we hope that people will share best practices and identify common pain points and eventually move towards solving some of those issues. We are open for anyone to join. Who here, show of hands, is involved in science somehow, broadly speaking? And any one of these people does software development? Keep your hands up. Okay. So we're looking to connect you with your peers. What you can do is you can follow us. We've been busy setting up our infrastructure. We have a Medium, as you can see. We have a newsletter. Oops, see, that's not good. That's why somebody recently said we have to move off of Medium because it's not open source. But you can do us a favor. If this is interesting to you, you can follow us on Medium, LinkedIn, and other channels. You can also check out one of the upcoming interest group meetings. These groups meet on a monthly basis. And that's pretty much it. It's under 5 minutes. So just wanted to make you aware. I actually have to run after this. I'm meeting somebody else in Heidelberg. But anyone going to Amsterdam for PyData besides Alexander? Okay, anyway, but I hope to be back. I'm actually going to be spending some time here I'm normally based in California. I'm going to be spending some time in Germany this coming school year and hope to be doing some events with maybe some of the other PyData meetups, maybe including PyData Southwest, and see if we can get some good connections going here. That's it. Thank you.
Cool. All right, wonderful. So, fix this here. All right. Okay, so let's It's good. There's no watch history there, right? So I'm lucky. No, I'm kidding. So where's the slide? Where are the slides? So the slides have disappeared. No, the slides are here. Right. So we had 3 great lightning talks. Thanks a lot for contributing to them. Okay, we don't have Slido here, so I have to move a bit forward here. Okay, yes, this is important. So yes, mentioned before, call for speakers. Some people approached me tonight, so we will have some talks, right, in the future. Where, yes, great talk coming up already. Lightning talk is also coming up. Serena here, right? Great. So it's important. So I expect we almost have every month a meetup coming up now. So we need content. We share your knowledge, prepare for the 2024 conferences. So I think having a talk at a meetup is really great to prepare and improve for a larger conference. Yeah, and we're happy to help. It's also your turn. Give us feedback. Host and sponsor us. Rate this event on Meetup. How you like it. You can reach out on social media with on Twitter, or now called X for whatever reason. Will people ever stop calling it Twitter, right? That's a big question. Now let me turn off the timer. So you can also send an email just to python@königsweg.com or reach out on LinkedIn to my profile. And we've covered that already. And yeah, thank you for being part of PyData Heidelberg today, and we continue with networking, and we say goodbye to the viewers on YouTube. There were quite a few. On average, there were like 40, 50 people watching, actually, somewhere in the world, which is not too bad. So we hope to welcome you back as well soon. All right. Thank you. Bye-bye.